Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty BAM! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
In space, no one can hear you scream. Or is that, in space, no one can hear ice cream? Well, either way, we know that no supernovas, crashing asteroids, and burning planets make a sound in space. Or do they? What if you actually can hear something out there? Well, let's see. Okie dokie, back to middle school. Sound is a mechanical wave originating from vibration. What exactly does that mean? Well, the simplest example is guitar strings. Let's pluck one of them. It starts to vibrate. The atoms inside the metal string begin to push and beat the atoms of the air around them. So now, atoms are constantly pushing each other until they reach our ears. It's like a wave from a pebble thrown into a pond, and it happens very quickly, at a speed of about 761 miles per hour. Then our eardrums begin to vibrate at the same frequency, and the little bones inside our ears transmit this vibration to the brain. The brain then does its magic, recognizes the pattern, and turns it into sounds. Great! Now we know that we need some particles to create sound, and we can find these particles in gases, liquids, and solid substances. And what about space? Nope, it's almost a perfect vacuum. And you've probably already heard that there's no sound in space because it's a vacuum. But what does it actually mean? Well, a vacuum is a perfect void. It's an area completely devoid of matter. It means there's nothing there. Yeah, despite all those celestial bodies in space, there's actually no air in between them. No atoms, no particles, nothing, nada, zippo. Well, almost. To be honest, the perfect vacuum doesn't really exist. We can't get rid of atoms for good. But space is very close to this notion. On average, there are 15 to 80 atoms per 1 cubic inch. This may sound like a big number, but keep in mind that these atoms are tiny, and the void distance between them is huge. For comparison, 1 cubic inch of air contains about 16,000 atoms. So, of course, with such a low density, these atoms can't push each other. Even if the vibration is very strong, like, a supernova, they still won't be able to do that. So, movies have been lying to us. All these epic space scenes actually take place in an awkward silence. Who would have guessed? But don't get upset. What if I tell you there are, in fact, some ways to hear sound in space? First of all, there's still sound on other planets. If there's an atmosphere on a space body, or at least something like gas, water, or a solid surface, there will be sound. In our case, the atmosphere becomes completely silent at about 60 miles above the Earth's surface. That's where the sky stops being blue and a black starry veil begins. In any case, we'd have to land on another planet, or at least get close to its atmosphere to hear something. But whatever it is, it would sound very different. Let's take our favorite Venus as an example. The atmosphere there is very dense. Scientists jokingly call it a thick chemical soup. No thanks. So, if you somehow managed to stay alive and speak there, your voice would be very different. It would become much louder and it would sound deeper. So, if you want a pleasant baritone, you know what to do. I wonder what would happen if Earth had a denser atmosphere. What would we hear then? Well, you can vaguely imagine that if you've ever been in the water. Water is very dense. Sound moves there much faster and better compared to the air, at a speed of almost a mile per second, depending on the water temperature. So if you sit in an empty room with no sound sources, you won't hear much, right? Now, dip your head in the water and check out how the same silence sounds here. It's not quiet at all. Even if you ignore the ever-present sounds of the water itself, you'll immediately notice how well you can hear your own body, how your blood pulsates in the veins, how your heart works, the slightest movement of your fingers. Kinda creepy, isn't it? This gives us an idea of what would happen to us on a planet with a denser atmosphere. And that's just crazy. We would hear everything. From scurrying animals to the movement of tectonic plates. Come on, you'd probably say. It's obvious that there's sound on other planets. But didn't you say we can hear something in open space? Actually, yes. For example, in a cloud of dust. You can find space dust almost everywhere in space. It may be the remains of a star or something else. And in these places, everything is a bit denser than usual. This means there are probably dust clouds where particles are very close to each other, which means they can produce sounds. Of course, those will be very quiet and transmitted over a very short distance. But it's better than nothing, right? Plus, we already have one real space sound recorded. It came from the Perseus galaxy, which is located 250 million light-years away from us. NASA recorded it in 2003. Those of us music geeks will want to know that it's a B-flat, 57 octaves below middle C on the piano. You'd have to add another 660 keys to the left on the keyboard. But its frequency is so low that the human ear unfortunately can't hear it. But besides that, we can only hear something inside spaceships. These are small pockets of air, after all. In a spacesuit, you would hear sounds very well, too, including your breathing or blood circulation in a spacesuit. But two astronauts flying side by side wouldn't hear each other, even if they got very close and shouted very loudly. It's quite funny. If you, being an astronaut, bumped into something, it would be very loud for you, but your friend wouldn't hear anything. That's why astronauts use radio devices.
291, cancel your call, 2879 will handle.
Now, purely theoretically, if you could somehow crawl out of your spacesuit and survive, you'd be able to hear the chatter and noises going on inside the spaceship. But how? So look, we have some air inside the spaceship and it transmits sound. It reaches the metal casing and gets through it. And then, if you leaned against the ship, preferably touching it with your elbow or knee, the sound would be transmitted to the brain directly through your bones, ignoring the ears. Yes, our bones conduct sound. That's how, for example, deaf people listen to music. It's called bone conduction. It's used in some headphones and some other technologies. You can do a little experiment. Hold your fingers over your ears. Shut them properly so that you really don't hear much. Then try to touch a sound source. It can be anything vibrating. For example, a speaker playing music with some part of your body where the bone is close to the skin. Now, watch the miracle happen. You can hear the sound not through your ears, but directly in your brain. But please, don't repeat this experiment in open space. Ice cream? Haha. Now, you've probably heard about things like the sounds of space, where you can listen, for example, to the sounds made by the sun or different planets. How do we record these ones? Easily. There is another way to hear sound in space: electromagnetic waves. In other words, a radio. Radio is the same form of electromagnetic radiation as light. These waves can travel in a vacuum without any problems. Astronauts' transmitters work that way. An astronaut says something to their friend. The sound waves turn into radio waves, reach the other person, and are then converted back into sounds. And this is how we get so-called space sounds. Our planet is actually very loud in that regard. We're sending a huge amount of radio waves into the universe, all radio signals we've ever listened to. It's a pity that they travel only 110 light-years away from us. But I think it's good that we don't hear everything that happens in space. Imagine if sound could easily travel through the universe. We would hear everything, from solar flares to nearby supernovas. Horrifying, right? So maybe we're just lucky. Hey, remember, in space, you can hear ice cream. Chocolate! Vanilla!
When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space, since the sky is always dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean less bright out there. If you were looking out the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day. Maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the Moon. But it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite, an orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the sun than our planet. So, when you're looking at the sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called mi-scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets Mercury, Venus, Earth, and Mars don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, Or they may be the remains of a moon that got destroyed by a collision with some space body, or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings. There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means that they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we know today as the Moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists call this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune and 10 times more massive than our home planet. It's likely to circle around the Sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the Sun as our planet and receives less sunlight and heat. But it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the Sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 miles per hour. Can they produce this heat? Or maybe it's because of the planet's core, or its gravitational force? There's a monster black hole hurtling through space at a speed of 5 million miles per hour. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful that they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. We'd have faced solar matter hurtling towards Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. They were caused by the storm. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from our galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint, pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue.
Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first?
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here, I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting a million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
The announcement day. Hello everyone and welcome to my space vlog. I'm so excited because I have a big announcement to make. After completing years of training, the day I've been waiting for all my life is finally here. I was always happy to be among the 350 people who have been selected to be NASA astronauts, you know. And here's a fun fact for you. The original 7 is included in that number. So it's fair to say I'm in the Legends League. But the great news is that now I'm finally done with the virtual reality lab and I'm actually going to go into space. There are so many things I need to do to get ready for my first mission. So I'll keep today's vlog short, but get ready to hear all about my space adventures in the upcoming days. The day before the launch. Now you would think the day before the launch would be a busy one for the crew, right? But it's actually quite relaxed in terms of things to do. Since the upcoming days are going to be stressful, NASA lets us spend time with some of our selected family members or friends who have been cleared to be near us during our pre-flight quarantine. We also get to stay at a beach house they own. Is this a dream job or what? But the most important thing we're advised to do today is to get a good night's sleep. That is, if you can, but no pressure. I'm going to try and do that now, so off to bed I go. It's a good thing that we were banned from drinking coffee 24 hours prior to the launch. Otherwise, I bet all the caffeine would prevent me from having peaceful dreams. Launch day. Today is the big day. First of all, although it's one of my favorite songs, I'm trying to avoid listening to David Bowie's Space Oddity, because ain't nobody wants any sad vibes. Secondly, coffee is not permitted for breakfast on the morning of the launch because of its diuretic properties. Having to use the restroom all the time can be a bit of a problem when you're going off to space in the cockpit, you know. Now, this may be a bit shocking for you, but other than all this, the astronauts have a significant chunk of downtime during a launch day. Before we depart for the launch pad, we do a final check and head to the restrooms for a pre-launch pee. Then it's time to climb into the cockpit. Many of us actually take a nap once we're there, as the system goes through thousands of pre-launch checks, including air-to-ground voice checks with launch control and mission control. And here's a fun fact for you. We wear adult diapers during this time, just in case. Alright now, let's eliminate talking about elimination for now. Well, now that everything is checked, it's time to start the main engine. Prepare for liftoff. 5, 4, 3, 2, 1. Woohoo! A day in space. Welcome to space. Now, I was going to say I will walk you through what a day for an astronaut on a space mission looks like now. But up here, I will float you through it. Now, first of all, every minute and every second of an astronaut's day in space is planned. From eating and brushing our teeth to working and sleeping, every move we make is based on a schedule. The things we have to do are planned down to 5-minute increments by a team in mission control called Ops Planner. This is crucial because these schedules show what is happening and who is involved with what at any given time on the space station. But don't worry, it's not all work and no play. Even if those are according to a schedule too, we still have free time to ourselves. Now, the concept of a day aboard an orbiting spacecraft is a bit different than what you might imagine. Every 24 hours, astronauts on board the International Space Station experience 15 sunrises and 15 sunsets as the station moves around the world. But for millions of years, humans have been living according to a 24-hour daily cycle. Our brains and bodies follow the circadian rhythm of waking and sleeping. That's why astronauts work and sleep to similar schedules that match these cycles and rhythms, because anything other than that would have us living in a state of permanent jet lag. Accordingly, an overall day for us looks like this. The workday is from approximately 6 a.m. to 9:30 p.m. Greenwich Mean Time, and it includes 3 meals and 2.5 hours of exercise. The morning routine. Our space morning schedule is sort of similar to our Earth morning schedule. We are awoken by an alarm, and we begin our hygiene routine with the stuff that is provided for us in our hygiene kits given by NASA. Those include rinseless shampoos that require very little water, since there are no genuine showers in space. The funny thing is, the water we use floats away during this. And each of us is allowed to take our choice of products with us in these kits, including cosmetics and toothpaste. There are razors to shave or clippers and scissors to give ourselves and each other haircuts if necessary. We just have to make sure to vacuum up that hair so it doesn't fly in our faces later as we're working. The food. We don't skip breakfast. It's the first of 3 meals we have, including lunch and dinner. When it comes to how much we eat, it really depends on the calorie necessities of each person. One great thing is that we don't really have to cook or do the dishes, since the meals are already cooked on Earth and come in disposable packages. You should know space food has improved greatly in taste and variety since Apollo missions, in which astronauts ate purely freeze-dried food for days. The space work. After we're done eating, it's time to get to work. Each of us settle down to the assigned tasks of the day. These assignments range from supervising experiments to performing routine maintenance on station equipment. Our work also includes checking projects that are controlled from the ground, as well as participating in experiments ourselves to figure out how well our bodies adapt to living in space for long periods of time. Space gym. Now, doing exercise is an essential part of our day. We actually commit hours every day to fitness. Normally on Earth, our bodies are constantly active because they're working against gravity to move. But with very limited gravity in space, movement is easier and doesn't require much work or energy. So, astronauts who spent a long period of time in space and didn't continue to train physically would lose a lot of muscle, which would leave them feeling weak once they return home. That's why it's vital for us to stay physically active to prevent bone and muscle loss. It also helps relieve what we call space snuffles that are caused by body fluids accumulating in the head due to not being tugged downward by gravity. Our regular exercise options include cardio using a treadmill or a bike. We do some weightlifting too. And to do all these, we have to strap ourselves down to the exercise machines because if we don't, we'll float away and our efforts would be for nothing. Free time. Mission organizers on Earth make time every day for us to relax and have fun here in space. This is when we write emails, watch movies, or even play an instrument. But to be honest, the most popular pastime in space is looking out the window to watch the Earth go by beneath you. There are also spectacular sunrises and sunsets to enjoy, which occur every 45 minutes as we orbit. So it's fair to say there's no time to get bored. By the way, just like Earthlings, we get weekends off too to recharge. Sweet dreams. It's important for us to get a good night's sleep to have energy for the next day's tasks. However, here in space, we can't climb into our beds. We have sleeping bags instead, which are attached to the wall to keep us secure. If they weren't, we'd be floating around all night, which sounds neither safe nor restful. Okay, I gotta go because I gotta go.
Two pictures are rapidly changing in front of your eyes: our huge planet and a black void. The picture of Earth is getting smaller by the second. You're flying away from the spaceship into an endless vacuum and don't know what to do next. The International Space Station flies 250 miles above Earth's surface. A spacewalk is routine for astronauts who work there. Astronauts have spent more than 11,000 hours in the black abyss to this day. Fortunately, during all this time, no one has ever flown away into outer space without coming back, as we've seen in the movies. But unfortunately, astronauts face other, no less terrible, dangers during spacewalks. One such accident happened in 1966. Eugene Cernan put on a jetpack and went into outer space to carry out some repair work. The jetpack, which helps an astronaut control flight in zero gravity, heated up a lot. Eugene put on special protective pants made of metal to protect himself from this heat. The pants protection didn't work when he went into outer space. Instead of directing the heat away from his body, the pants began to heat up. The suit was heavy and uncomfortable, like a knight's armor. It rubbed his skin and restricted movement. Working in zero gravity is physically very hard, but Eugene also had to deal with his whole suit heating up that day. Inside the spacesuit, he felt like he was in a hot bath. High temperatures and hard work caused overexertion, dehydration, and severe weight loss. His face was sweating, and drops of sweat blinded him. During this spacewalk, the astronaut lost about 13 pounds of weight. Other astronauts came to the rescue and took him back to his spacecraft. To reduce overheating, they sprayed him with cold water from a hose. In a sense, to go out into an infinitely huge open space, an astronaut must put on a suit resembling a body cage. Another dangerous incident happened in 1973. Two astronauts, Pete Conrad and Joe Kerwin, went into outer space to repair a solar wing on the Skylab space station. The wing didn't turn around, and the astronauts tried moving it manually. Using force, they turned the stuck wing, but it pushed them. The push was so strong that it threw both astronauts aside. They didn't have time to grab onto a nearby surface and began to fly away into outer space. Fortunately, they had safety cables that didn't let the astronauts go away for good. By grasping them, the astronauts returned to safety. In an ordinary modern spacesuit, there are more than 10 protective layers. Such a suit protects against extreme cold and hot temperatures. It's tear-resistant and doesn't leak moisture from the outside. This protection is necessary to prevent depressurization. If a small passage appears between your body and space, then all the oxygen will start coming out of the spacesuit. The more oxygen the suit loses, the more vacuum it gets. This leads to terrible consequences, such as suffocation and increased body volume. It looks as if you start to inflate from the inside. In 2007, Rick Mastracchio went into outer space to do some repair work. For some reason, there was a hole in his left glove next to his thumb. It was on the outer layer of the glove. But the worst thing was that the astronaut hadn't noticed it. He continued to work as if nothing had happened. But one damaged layer could destroy the second. The second one could tear the third one, and so on, until the vacuum reached the astronaut's skin. Rick was supposed to work 6 hours in outer space, but during the 4th hour, he noticed the damage in his spacesuit. The astronaut reported this to command and received an urgent order to return to the ship. He never found out how the hole had appeared. Inside the ISS, there are many chemicals necessary for working in space. For example, ammonia has the property of freezing almost any surface. This chemical frost is used to cool some components of the station during overheating. The leakage of this substance on the ISS is practically impossible. This is exactly what astronaut Robert Curbeam heard from experts during the training before his first flight to space. But this accident occurred to him on his first spacewalk in 2001. Robert was working outside the space station when an ammonia leak started. The liquid splattered all over his spacesuit. A thick layer of ice quickly covered the glass. Robert didn't see anything. He feared that he had broken something, but the accident was not his fault. The protective layers of the spacesuit didn't allow Robert to freeze, but the ammonia severely restricted his movements. The main problem was that he couldn't return to the ship. Ammonia could get into the station, and this could lead to an emergency. Robert had to stand in outer space for 1.5 hours and wait for the leak to end. After that, he successfully returned to the station. To realize how difficult work is in outer space, we need to understand what a spacesuit is. It weighs 280 pounds, which is as much as a scooter. You won't feel its weight in zero gravity, but it will still make you sweat. Astronaut Chris Hadfield had described it by saying that every movement inside your spacesuit meets resistance. The suit scratches your skin, squeezes your bones and joints, and forces you to spend twice as much energy on simple movements. In such conditions, you start sweating and your eyes get wet. This moisture flies inside the helmet and blinds you until it evaporates. But if there's too much moisture, it can threaten the life of an astronaut. Such a case happened in 2013 with astronaut Luca Parmitano. He went into space to measure something outside the station. At one point, he felt that the back of his head was wet. He informed the others about it and got an order to return to the station. When Luca was coming back, he had to turn upside down. As soon as he did this, water gushed into his helmet. It covered most of his face. Luca couldn't see or hear. He tried to report the trouble to base, but the water covered his mouth. Fortunately, his partners rescued him and helped him return to the station. When they opened the helmet, almost half a gallon of water poured out. Astronauts' cables are some of the most reliable defenses against floating away into space. But what if one broke from a strong push, or because the astronaut didn't fix it well? For additional protection, there's a backpack called SAFER, Simplified Aid for EVA Rescue. It's like a jetpack. It releases gas from small tubes and changes the direction of your flight. If you're spinning in space, SAFER stops and aligns your movements. You can take manual control and fly using a special joystick. SAFER was first used in 1994, but before engineers created it, there was the MMU, the Manned Maneuvering Unit. In 1984, astronaut Bruce McCandless used it for the first time. You may have seen this famous photo where he floats in outer space without a cable. The problem was that Bruce was the first tester of such a jetpack. He wasn't 100% sure if it would work. He went into outer space and unhooked the cable from himself. There was nothing else to keep him from flying into the infinite black abyss, and his team wouldn't be able to save him. Imagine how scary it must have been. Fortunately, the jetpack worked. However, after 3 missions, NASA decided to stop using the MMU as it was unsafe. After that, engineers invented safer. Jetpacks and cables are reliable safety systems, but the best protection for an astronaut in space is their skills. Each astronaut has 6 years of higher education and several more years of training. They spend many hours training in virtual reality with spacewalk simulations. They train their body, endurance, and mind, since the main thing in a dangerous situation in space is not to panic and stay calm.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
Aristotle once said that gold was water solidified in the ground and mixed with the sun's rays. Others were sure that gold was made with the help of the Philosopher's Stone. When the ancient Incas first saw gold, they decided that this metal, falling from the sky, was the tears of a mythical creature. But its real origin seems much more epic. Let's go to a very distant past, to the time when there were no people or animals, to the time when dinosaurs didn't exist yet. to the era when the simplest forms of life were just being formed. Our planet resembled a huge cauldron of chemical elements. There were erupting volcanoes, earthquakes, and lightning flashes all the time. It was about 3.9 billion years ago. During this period, huge asteroids flew through our solar system. They fell on Mercury, Venus, Earth, and Mars. It's possible that asteroids also fell on the moon and left large craters on it. There was a real apocalypse on our planet. But fortunately, no one felt it because there was no life yet. Along with the destruction, the asteroids brought metals. But were there metals on Earth before that? Of course. The core of our planet is mainly made up of metals such as iron. From there, it spreads to Earth's crust, mixes with magma, comes into contact with oxygen, and combines with other elements. But how did they get into the core? Simple hydrogen and helium atoms merged and formed heavier elements inside giant stars. Then, supernovae exploded and formed big clouds of dust and gas. These clouds reached our galaxy and began to revolve around the sun. Over time, this dust and the remnants of stars formed planets. One of them was our Earth. Metals lying in the bowels of our planet are difficult to get, and we wouldn't have the technology we have now if it wasn't for that meteor shower that left metals on Earth's surface. There are two theories. The first suggests that powerful supernova explosions far from our universe formed a lot of metals from the periodic table. During the explosion, nuclear fusion started, and it created atoms of gold. Then, the blast wave threw those hot pieces in different directions. They flew for a long time, cooled down in cold space, and reached our solar system. Another theory says that gold and other metals appeared because of the merger of two neutron stars. These are powerful giant stars that are many times smaller in size than the Sun, but several times heavier than it. These are objects with tremendous gravitational force and density. Their collision formed an intense gamma-ray burst of radiation that could synthesize gold. In 2017, astrophysicists observed the collision of two neutron stars for the first time. They found traces of heavy metals, including gold, using gravitational wave detectors. So this theory seems more likely. And what if we go even further? Where did stars come from? Clouds of dust and gas are scattered throughout the universe. They mix, combine into one mass, and grow like a snowball. They squeeze each other and form a gravitational force. When all the material collapses, it starts to heat up. And then, this surge of energy creates a star. Some physicists assume that stars, during their lifetime, can produce most of the elements of the periodic table. If this theory is true, then our body also consists of stars. We may be part of some gigantic supernova that exploded billions of years ago at the other end of the universe. More than 50 years have passed since the appearance of this theory, but no one has proved or disproved it. Okay, let's get back to gold. One of the largest gold deposits in the world is in southern Africa. Scientists believe that the precious metal appeared there more than 2 billion years ago after the fall of a giant meteorite. People are sure that gold is hidden in the world's oceans. Anywhere from 10 to 20 million tons of this precious metal can be underwater. But those are not large stones, but tiny particles dissolved in liquid. The extraction of such gold is too expensive. Now, let's find out how people mine gold and turn it into jewelry. At first, people find gold deposits, large plots of land or rock inside which gold is hidden. Workers begin to use picks, shovels, and machines to extract shiny pieces from the rock. Then these pieces are dissolved in a special acid that separates the gold from the solids. After that, other substances get removed from the precious metal by melting or using gaseous flora. When the gold is purified, it's checked for purity. 99.9% is the benchmark. Done! Your gold is ready to use. You can turn it into jewelry or part of an electronic device. The rarest metals on Earth also got here from stars. I'm talking about rhodium and iridium. They are several times more expensive than gold, not because of their beauty, but because of their practical value. For example, rhodium and iridium can turn harmful gases into harmless ones, and 90% of the demand for this metal falls on the automakers market. People use these metals in the manufacturing of auto catalysts. They are needed to clean harmful exhaust. When toxic substances produced during fuel combustion come into contact with these precious metals, they become their safer forms. A microlayer of rhodium and iridium is applied to the walls of the catalyst cylinder. Gold, platinum, rhodium, and iridium are the most expensive metals. But what about the most durable ones? It's a little complicated to determine one winner because the strength of a metal depends on 4 criteria. First, there's tensile strength. This is the ability of a metal to resist tearing. For example, modeling clay has a low tensile strength because you can easily stretch it in different directions. Among metals, tungsten is perhaps the most difficult to stretch. Another criterion is compressive strength. This is the ability of a metal to resist compression. And here, chrome is one of the strongest. The third criterion for the strength of metals is yield strength. To test this, you need to make a rod or beam from any metal and then try to bend it and break it. The metal that shows the greatest resistance has a high yield strength level, and titanium is pretty good for that. And the fourth criterion is impact strength. This shows how strong the metal is when it gets dropped or hit. In this regard, iron shows a good result. Each metal has its own strong and weak sides. Chrome, for example, has a high resistance to compression, but it's weak if you try to stretch it. Therefore, people make metal alloys to combine their strengths. Okay, we've learned about the rarest and most expensive metals. And what about other elements? What's the rarest substance in the world? Meet astatine, the rarest element on the planet. There are about 0.8 ounces of this substance found in the whole world. The rate of its decay is equal to the speed of its formation. Therefore, the amount of the substance in nature doesn't change. People discussed it in the 1800s and discovered it at the end of the 19th century. But even now, after so many years, we know little about this element. In 1869, the creator of the periodic table, Dmitri Mendeleev, learned that there was a certain substance numbered 85 in the group of halogen elements. This group of nonmetals includes such substances as fluorine, chlorine, bromine, and iodine. So astatine is considered the heaviest of all known halogens and most similar to metals. It has a low melting point and conducts heat and electricity poorly. It's brittle in solid form and has a dark color. Even today, scientists don't know all its properties. It's almost impossible to find it in nature, but chemists have learned to synthesize it artificially. People don't know how to use this element because it's too radioactive. But in some laboratories, scientists conduct experiments using astatine to treat thyroid diseases.
No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes.
Astronomers have been asking one question for decades. Is space really as black as we think it is? Well, NASA's New Horizons space mission might have just given us the answer. After exploring Pluto, the spacecraft kept going and is now billions of miles away from Earth. This means it's far from all the light pollution we get from sources like the sun and dust particles around our planet. Scientists used the spacecraft's simple camera to take images of what looked like incredibly boring blank space, free of bright stars or anything else that could scatter light back into the camera. They then processed these images to remove all known sources of visible light. Once they'd removed the light from stars, plus scattered light from the Milky Way, they were left with light coming in from beyond our own galaxy. But here's the surprising part. They found that there was still plenty of unexplained light. In fact, it was about equal to all the light coming in from the known galaxies. That means there's just as much light outside of galaxies as inside them. So, where does all this light come from? Well, it could be coming from sources we haven't yet discovered, like small, faint dwarf galaxies or unknown phenomena out in the universe. Or it could be associated with dark matter, which is still a mystery to scientists. With this groundbreaking research, we can say that space isn't as dark as we know it. What if we take all the light from the stars and galaxies out there and throw in some gas and dust clouds? What color do we get? Beige. This leads us to another question. Do we still need the sun if our space is colorful? And the short answer is, yes, we do. The colors of space are a result of the interactions of light with different celestial objects, such as stars, galaxies, and gas clouds. While these colors are fascinating to observe, they do not provide the energy life on Earth needs to survive. There you go. Don't expect to see the color of the sky in space. When you think of astronauts going to space, you probably imagine those cool things they can do up there. First of all, it's flying like a superhero all the time. Astronauts hold onto rails and use their arm strength to move among modules. It probably takes some time to get used to this way of moving around, but in a couple of months in space, they can become real acrobats. They also read books, watch movies, or take awesome pictures of Earth through the cupola windows, which is a special viewing area on the space station. They also invent new games, like the one where they try to hit a target, or where they race one another from one end of the station to the other as fast as they can. And zero-gravity sports must be so cool. Imagine playing soccer up there. It's the only way I'd ever be able to do a bicycle kick properly. It's cool how they eat or try to catch a bite from a floating spoon. But besides all these fun things, they need to sleep too. And that's not so easy in space. Not having gravity can be cool when you fool around and fly across your chamber, but it's definitely not that great when you're tired and can't wait for your head to hit the pillow. Because in space, that won't happen. Instead, astronauts have to sleep in small sleeping bags attached to the wall. This way they won't float around or potentially bump into things while they're sleeping. No sleepwalkers up there, only sleep floaters. Astronaut orbited our home planet a whopping 17 times in a spacecraft, proving humans could live, work, and sleep in space. But just because it's possible doesn't mean it's easy. Some astronauts described their space capsule as a small garbage can, and the cabin itself is about the size of the front seat of a Volkswagen Beetle. Sleeping in space is very different from sleeping on Earth, to say the least. There is no up or down in space, so astronauts can choose any position they find comfortable. On the International Space Station, sleeping quarters are about the size of a phone booth. It's a tight space, and it doesn't look as cool as the rest of the things up there, but they make it work. Astronauts have to sleep near an air vent to make sure they have good ventilation. Breathing is trickier in space because the carbon dioxide they breathe out can form a bubble around their heads, which can be problematic since they may not get enough oxygen. Astronauts cover up windows to block out sunlight and may wear sleep masks, just like some people on Earth do to block out light. The sun in space can be really bright, even with window shades, because there's no atmosphere to filter sunlight. Oh, those things we take for granted down here. Also, the space station orbits Earth every 90 minutes, so astronauts get to see a new sunrise every hour and a half. The station can be noisy too, since they have all those fans and other equipment, so astronauts sometimes wear earplugs to help them sleep. We all become grumpy if we don't get enough sleep, with or without gravity. Not just that. A lack of sleep can affect our blood pressure, immune system, balance, and health in general. And it's way trickier when you're not feeling well up there than on Earth. NASA schedules its astronauts for about 8 to 8.5 hours of sleep per day. But those who work on the ISS, on average, go with 6 hours of sleep, because the space environment can disrupt their natural sleep patterns. That's why it's not so unusual to have insomnia and sleep deprivation when in space. Astronauts sometimes have changes in their schedules. They have to work long shifts or finish tasks assigned at night. All this works against good sleep. That's why NASA has sleep education and promotes special relaxation techniques to help crew members sleep better. Dreams and nightmares are as common in space as they are on Earth. You just can't get away from your mind making up different scenarios while you're sleeping. And you know that feeling when you first wake up all groggy and sluggish? It's like your body and brain are still trying to catch up and fully wake up. You might feel a little bit disoriented, plus it might be hard for you to think clearly or move quickly. It's called sleep inertia. This feeling usually goes away after a little while, but it's probably way harder to get rid of it in space because many astronauts have issues with it. And even if you had perfect conditions for sleep, just being in space would probably disrupt your body's natural sleep-wake cycle. Two things regulate this cycle: the S process and circadian rhythms. The S process controls whether we are asleep or awake throughout the day. In space, your body gets less deep sleep, which means it goes through some changes in the S process. Circadian rhythms help regulate our internal body clock as well. In space, where such cues as exposure to light and darkness are a complete mess, you can't simply set your alarm clock at 7 a.m. every morning. At least up there, I'd have a good excuse for not doing this. To help astronauts adjust, NASA has added special lighting inside the space station, which mimics a regular day on Earth. They try to block out outside light at night and provide enough light during the day to help astronauts stay awake and sleep at the right times as much as possible. Astronauts need to be careful not to get exposed to blue light from electronic devices because that disrupts sleep too. That tip sounds familiar. We need to figure out as many tricks as possible to get better sleep because we don't want to go on a mission to Mars and come to our potential new home all grumpy and moody. Plus, people who will go on these special space missions won't have as much space as astronauts on the ISS. Their quarters may not be like the comfortable bedrooms they have back on Earth. but they will still be dark, quiet, and best of all, private. At the same time, say goodbye to privacy on your way to the moon. On such missions, there will be less space for crew members to sleep. It will be like camping with your friends, but with not enough tents. And imagine jet lag in space. It usually hits astronauts even before they get to the space station. To help with this, they start adjusting their sleep schedules a few days before they launch into space. They change their sleeping and waking times to match the time of day and time zone of their launch location. Once they reach the space station, where astronauts from different countries work together, they all switch to using a common time called Greenwich Mean Time, GMT. This helps everyone synchronize their schedules because it's a middle ground time that can be easily understood by people from different parts of the world. So to help crew members have better sleep, scientists have simulated space missions on Earth. They have a special habitat called Hera at Johnson Space Center, which is almost the same size as a lunar base or spacecraft. Crews live there for certain periods, and researchers study their sleep patterns and performance. NASA is planning a cool experiment called the Crew Health and Performance Exploration Analog, SHAPEA. The first mission is supposed to start soon with 4 crew members, a commander, a medical officer, a flight engineer, and a science officer, living in a habitat called Mars Dune Alpha at NASA's Johnson Space Center. They will live in the 3D-printed habitat and exercise, cook, clean, do other things, and collect data just like they would on the Red Planet. I mean, we still have a decade or two till the first human missions on Mars, but we better hurry and prepare well.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist. It's just that you can't hear them. There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first. Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, But something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads. And we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey, smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
Space travel has come a long way since Sputnik was launched into orbit in 1957. Since then, we've sent humans to the moon, set up the International Space Station, and even sent robot spacecrafts to explore other planets. But there's still lots more to discover and achieve in space. So, what are our current plans? What technologies are we developing now? And what awaits humanity in the next 100 years? Let's find out, shall we? First of all, artificial intelligence. Fun fact, my high school history teacher claimed this is what I had as per my test scores. Right now, humanity is actively engaged in the development of artificial intelligence, and we've already made a bunch of breakthroughs in this area. With the help of AI, we're going to be able to explore the cosmos like never before. Think about it. AI can automate and optimize tasks like mission planning and data analysis. Now, human astronauts can focus on more important things, like looking for some non-human astronauts. Plus, AI can control and operate spacecraft remotely, reducing the need for risky human missions. And that's not all. This super smart technology can also provide unique perspectives and insights that humans might have missed. AI could also help us understand the data collected by space probes. In short, the use of AI in space exploration will help us learn more about the cosmos and make exploration more efficient and cost-effective. And this isn't the only thing that will help us in conquering space. Next, reusable rockets. Gone are the days of one-time use rockets. These days, reusable rockets are taking over the space industry. Not only do they save money, but they also make space travel more accessible to a wider range of people and organizations. To date, the SpaceX company has created a bunch of reusable rockets, like the Falcon 9 and Falcon Heavy. They've completed many successful missions to the International Space Station and beyond. Blue Origin has also made great progress in reusable rocket technology with the New Shepard. It's even planning to take paying customers on trips to space soon. Alright, so these cool technologies will help us get up there. But what are we going to do next? Moving on to building settlements beyond Earth. Space colonization, here we come. The possibility of establishing colonies on other planets, such as Mars, is a dream that has captivated humans for decades, and now it's finally within reach. But before we start packing our bags, here are a few obstacles we need to overcome. For starters, getting to Mars is no easy feat. It's a long journey that could take months, if not years. So first, we need to figure out how to keep humans alive and healthy during the trip. Now, once we get there, we'll face even more challenges. The harsh radiation and extreme temperature fluctuations are just a couple examples. Living and working in space isn't easy either. We need to make sure that everyone has what they need to survive. It's not like you can just go to the store for supplies. So we'll have to build systems to provide food and water, create some advanced transportation, and maintain all of that in good condition somehow. Finally, let's not forget about the most important thing: money. Building and maintaining a settlement beyond Earth is no small feat, and it will take a lot of resources and cooperation to make it happen. But there are still great benefits in living in space. It opens up many opportunities for scientific research and exploration. We'll be able to learn more about the universe and our place in it. So, no dream too big. Even though it's a big challenge, it has the potential to be really rewarding for humanity. That's why private companies and space agencies are already working on plans to send humans to Mars and potentially even terraform the planet. Actually, let's talk about that. Terraforming. The dream of turning a barren, inhospitable planet into a habitable paradise. Sounds like something straight out of a sci-fi novel, right? Well, believe it or not, by using advanced technology and resources, we could potentially turn deserts like Mars into beautiful Earth-like worlds. But here we also have a few hurdles to jump through first. Terraforming isn't exactly a quick process. It would take lots of time and resources to make any significant changes to a planet. There are also some ethical dilemmas to think about. If we start trying to change the Martian ecosystem, We could potentially wipe out any existing life forms. Imagine if someone did that to us. Actually, we've been doing it to ourselves. And finally, there's the cost. Terraforming would be a major expense, and it's not clear who would foot the bill. It would likely require the cooperation of multiple countries and organizations. But even with all these challenges, this is still an exciting prospect. Who knows? Maybe one day we'll be able to turn Mars into the ultimate vacation spot. And that's just the beginning, because we won't stop at Mars. Our next goal is asteroids and other celestial bodies. Now picture this: you're floating in your spacesuit, mining an asteroid for some seriously valuable resources. You strike gold, or rather a shiny vein of platinum, and head back to Earth to sell it for a fortune. And with the money, you fund even more space mining expeditions, becoming the ultimate space tycoon. But seriously, space mining could be a game changer for space exploration and the economy. Imagine being able to extract water from asteroids to sustain human settlements on other planets, or mining rare minerals to use in high-tech industries back on Earth. The economic benefits could be massive. Of course, there are also challenges to overcome. We'll need to figure out how to safely and sustainably extract resources from asteroids. We also need to make sure that space mining is done in an ethical and fair way. But once we deal with all this, it'll change our lives forever. So let's get to work. But once we've mined everything, what awaits us next? For example, what lies beyond our solar system? Interstellar travel and the search for life. We've already made some amazing discoveries in our hunt for extraterrestrial life. For example, NASA's Viking landers and the Galileo spacecraft have given us some clues about it. Also, in 2022, we found traces of organic matter in the former Martian lakes. We're not sure yet, but perhaps Mars was once as prosperous as Earth. But we all know that the real excitement lies beyond our solar system. Scientists have already found thousands of other distant exoplanets, and some of them are in their star's habitable zone, meaning they could potentially support life. So our next step is to send probes or even humans there. Imagine being the first person to set foot on another planet, discovering microbial life, or maybe even a more advanced civilization. Talk about out of this world. And maybe, one day, traveling to another star system will be like a regular road trip, except instead of a minivan, you're in a spaceship. And instead of stopping at a rest stop, you're stopping at a new planet. Sounds awesome, doesn't it? Right now, there are a few ideas about how we might make interstellar travel a reality. One possibility is the use of wormholes. These hypothetical tunnels in space-time could potentially allow us to travel vast distances in a shorter amount of time. It's like taking a shortcut, except instead of cutting through someone's backyard, you're cutting through the fabric of the universe. Pretty crazy, huh? Another option is antimatter propulsion. This involves using antimatter, which is the opposite charge of our regular matter, as fuel for a spacecraft. When it comes into contact with regular matter, it releases a huge amount of energy. Imagine your car's gas tank being filled with antimatter instead of gasoline. That's going to be a powerful ride for sure. Of course, there are still lots of challenges to overcome before we can make interstellar travel a reality. But let's hope that one day we'll all be able to pack our bags and hop on a spaceship for a trip to the stars. Anyway, the future of space travel is looking bright. With all of these advancements in technology, we're excited to see what feats of exploration the future holds.
Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, Watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's gonna take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the Red Planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos